Welcome to the 19th session on operating system and Linux. I'm Manibhushan D'Souza. In today's class, we are going to look at critical region. In particular, we are going to look at monitors. We are all familiar that we can use a semaphore to achieve the process synchronization. So, semaphore can provide an efficient method to share the data between the two concurrent processes so that they can synchronize with each other. And we have seen the examples where we can achieve that thing. However, there are some problems with the semaphore. Even though I won't show you the programming way how the problem occurs, but just to summarize, whenever we use the semaphore for achieving the synchronization, if you are not careful with the calling the wait and signal method, what will happen is there will be some timing errors. And when there is a timing error, you will not be able to synchronize the activity. Remember, this kind of error does not occur in a general execution. They occur at some particular sequence. Only if that sequence is called, then the timing error will lead to the process not getting synchronized. Okay, so this is a bit difficult because it does not always occur. Okay. So the next question that comes into our mind is then how can we achieve the semaphore? Now we know that semaphore is a low level routine that is being used up. Now why can't we think of having a high level synchronization construct? And that is what is a monitor. So monitor is a high level synchronization construct. What do I mean by saying it is a high level synchronization construct? We know that in programming language we have high level programming language and we have low level programming language. What is high level programming language? High level programming language is your common English like language, and low level, you know very well, is the hardware related programming language. In the same way, the semaphores were at the lower level, and we are thinking about achieving the synchronization directly in the programming language itself. So we have been using the different programming language like C, C++ and so on, wherein we have a different programming construct. Like we have if statement, we have while loop, we have for loop, and all of them are construct which are directly part of the programming language. Now just imagine what if you are given a programming construct like if, while, or for, which will achieve the synchronization. So you will achieve the same functionality as that of the semaphore by using the construct which are part of the programming language. And this particular construct is the monitor. So you will be able to easily control the synchronization activity with the help of the monitor. And in fact, monitor is being implemented in many programming language, or the famous programming language all implement the monitor, which you can directly make use of. So let's define what is a monitor. A monitor is nothing but it's a high level synchronization construct that allows us to safely share and abstract data among the concurrent process. So when there are more than one process which are executing, we can safely share the data in between these concurrent processes. Okay. Now let's look at the monitor. Now when we talk about the programming language, we know that there are different data types are available in the programming language. We have integer type, we have double type, we have float type, we have character type, and there are different operators which work on those data type. Like we know that if you have two numbers like integer number 5, you can add them together, but in many programming language, if you have two characters, you cannot add them. So this add operator, that is the plus operator, does not directly operate on the character or string in most of the programming language. Okay, so We also have the monitor as a type, like you have a integer type, float type, or double type. Similarly, monitor is also a type. Okay, so you can think of creating a variable of type monitor, so that will be easier. When we say it is a type, there must be some operators that will operate on them. Okay, so if you have a variable, let's say if you have a variable, let me call it as int I, then I can somewhere I can write I plus plus. So somewhere I can go here within my program and then say I plus plus. So plus plus operator works on it. Similarly, when I have the monitor, which is a type, I can also have a type. I can also have a operator that operates on it. Okay, so when we talk about the monitor, and when we declare the monitor, we can think of monitor as a structure, not just a int or float, which is a fundamental type. Everybody has studied about C programming language, I suppose, and you know something about struct, that is structure or union. In the structure, what we have is we can create variables inside the structure. And I hope you have studied the object oriented programming like C++, wherein you can create a object. So what is there inside a object? See, object consists of, if you take a object, so a object consists of some variables. So there will be some variable and some methods which can operate on these variables. So methods or procedure and the types, everything put together as a single unit. So similarly, you can think about the monitor in the same way. There will be some data type which you want to share. So there will be some data type and there will be some procedure that will operate on these type. So that is what you have. So these values which are stored in those variables define the state, that is called as instant. Now again, if you have studied the object oriented programming, you declare a class which is nothing but a blueprint that will tell how many variables are there, how many procedures which will operate on them, and then you derive an object out of that particular class. This object has a state. Why do you say object has a state? Because there will be some values which are instantiated, which are given during the instantiation. So similarly, monitor can be instantiated by giving some initialization value. So when you do that, we say that this is an instance of a monitor, and all these procedures can operate on the values that you have stored. Okay, so that's how it goes. So let's look at a monitor, a programming way of looking at the monitor, and you know very well. Compare this with your class that you have created in C++ or Java or any other, if you know the programming language. So when you create a class, you say class name. Here you say monitor name. Then you have the variables, that is instance variables. Here we have shared variable declaration. Then we have functions there. Here we have procedures. That's all. In the class you have constructor, but we have the initialization code. So if you look at this particular thing, it looks like a class declaration itself, but it is a declaration for a monitor. Okay, so a monitor will consist of a procedure and variable and maybe other data structure, everything put together as a single unit. How you have a class that encompasses the variables as well as the procedure as a single unit, you are also creating the same thing. Okay, so procedure that you write in your monitor can only access the variables which are declared locally apart from the formal parameters. So what do I mean by saying that is, when you have the functions inside the class, the function can get some values from the user, that is nothing but formal parameters. Apart from that, they can operate on the instance variable. So if you have written a class, then you know what I'm talking about. So when you create a object, the object can receive something from the outside environment using some methods. So you call instance method and you supply some values. That method will perform some action and change the state of the object. The same way here also same thing, you have procedure which take up the input parameter and they will change the state by making changes to the local variable. Again, if you have created a C program or any other programming language, if you declare a variable as private, so private int x or int y or something, then that will not be exposed out to the world. Similarly, local variables in the monitor are not exposed out to the world. They can directly make changes to the shared data. So there must be a procedure that you can use it. Okay, so now you may say that okay, now that I got it. So it is like a class, and I declare a class or a structure, I can achieve it. Now the next question is, what's so great about it? The greatest thing about declaring a monitor or declaring the or a difference between a class and the monitor is that when you declare something as a monitor, it will ensure that only one process is using it or one process is active within the monitor. So somehow, suppose if you declare a class and if you declare a object, then many processes can simultaneously, if you are not careful, can make changes to the state of the object in if it is a class and object. Whereas in the monitor, if there are many processes are there, they will have to wait in queue. So they only one of them will be active, and this is done automatically by the programming language. We don't need to do anything. So how a for loop works, how a while loop works, we don't need to bother about it. We have to just use the while loop and we have to just use the for loop. But there is some way in which it achieves that thing. We don't bother about it. We leave it to the programming language. In the same way, monitor will ensure that only one of the process will be active. How it does, as a programmer, we don't have to bother because the programming language will take care of it. So I don't have to write any synchronization script to achieve the process synchronization. So if you want to see it visually, this is what you have. So we have some shared data, and we have some initialization, like we have the constructor, and we have some methods which you can use it, and at a time only one of them will be active, all the others will have to wait in a queue. So this is how the monitor will work. Okay, the next question is how can I achieve the synchronization? Okay, you said that at a time only one of the process will be available or will be allowed to use the monitor. That means to say that there must be a way in which the others have to wait. Okay, how can we achieve that thing? To achieve this, we have something called as a conditional variables. So these conditional variable will be used for achieving synchronization. Suppose if you want to write your own code to achieve the synchronization, then what you need to do is you have to declare variable of type condition. Now condition is only the word that is given. The different programming language may have different keywords for that, but just to give you, so I declare a variable of type condition. Now this conditions variable have only two methods, and guess what, which are those methods? One is the wait, other one is the signal, same as the semaphore, but here you have a variable. So how you declare int, float and other things? You declare condition variable where are only two methods are there. One is a wait, the other one is a signal. Suppose if a process calls, suppose there is a variable which is declared as a condition, and if a process calls wait, what is going to happen is then this process cannot proceed. So you are just, it is like you are closing the gate. You don't allow, when the wait is called on X, the gate is closed. Somebody else has to open this gate. So in other words, a process comes here, and if the process calls X wait, this process is halted on X. Somebody else has to call signal on this. So when somebody calls a signal, this gate is open and the process can continue. So when you call wait, the existing process or invoking process will be suspended until somebody calls a signal on them. Okay, so simple idea is that. Now, what happens if you call a wait and signal on the semaphore? The same procedure that you notice. When you call wait on a semaphore, s is equal to s minus 1, provided s is not less than 0. And what is the signal? S is equal to s plus 1. Remember, there is a one subtle difference between this monitor and the semaphore, and that is, in the semaphore, if you call signal, then without checking, what the semaphore will do is, it's going to say s is equal to s plus 1. It automatically calls as s is equal to s plus 1. Now what happens is, if s is 5, if s plus 1 will be 6, s plus 1 will be 7. Now what is happening is the state is changing. The value, when you say value is changing, that means the state is changing. So if you just look at a switch there, if you change the state, it becomes off or on. That means the value is changed. Switch is on, the value is on means light will glow. Value is off means light will not glow. Similarly, when you change the value, the state will change. You are there in the first year, you came to the second year, so your state is changing. So values are changing. So when you call the signal, what happens is the values are changing. That means the state of the semaphore itself is changing, but that is not the case in the case of monitors. In monitors, values don't change. If you call a signal on already open, so suppose if the gate is already open, everybody can enter. If you call signal, the gate will not be again open. So it is like, if the switch is already on, if you press it again on, again it will not on, it is already on, so it will not change the state. But if you call wait, then it will be off. So it is like, if you switch off, then it is cut off. So if it is on, you can cut off. It's off, you can start. Okay, so that is how it goes. So this is a subtle difference between these two things. Now we can use the monitor to achieve that thing. So if you look at the idea over here, so what happens is, whenever you have the condition variable, so if the condition variable allow only one of the process to proceed, but all the others, like how you have the queue here, waiting queue, all the others will have to wait. So this is how it is. Again, it is achieved automatically by you. I am not going to show the programming equivalent of it. So the condition, it's like you have the watchman in front of ATM. So if he is on duty, what will happen is, if one person is entering, he will not allow the others to enter. Only when they come out, he will allow the others to enter. So in the same way, here you have a conditional variable which will block or which will allow the other process. And again, this is achieved directly within the programming language. That's all with respect to the monitors. If you are really interested in knowing more about the monitors, please refer the Galvin's book. Thank you for your interest.